All right, so we need to determine whether the series diverges, converges absolutely, or converges conditionally. So the first series is we look at that. If we look at the nth, I know that I can't use the alternating series test because as n goes to infinity, this is going to go to 1. It doesn't go to 0. So the nth term test says that the limit as n goes to infinity, this is not equal to 0, so automatically this diverges. So I know that A diverges. Okay, for B, we're going to use the alternating series test. So first we need to determine that they're less than, that the n plus 1 term is less than the n term, which they are for every single term. So we're going to take the limit as n goes to infinity, and noted that this gives me infinity over infinity, which is indeterminate form, so I'm going to use L'Hopital's rule. Okay, so if I use L'Hopital's rule, it's again going to give me infinity over infinity, so I'm going to use L'Hopital's rule again. So I'm going to use L'Hopital's rule many times until eventually the numerator is 1, and the denominator is still 3n minus 1. So it's going to be 1 over, as n approaches infinity, this is getting smaller and smaller and smaller. So this is going to 0. So this converges by the alternating series test. So now let's look at the absolute value of this series. And look what happens then. Okay, so what we're going to use is we're going to do the ratio test. We're going to take the nth plus 1 term and we're going to divide it by the nth term. So if we cancel out the 3 n's, okay, we're left with nth plus 1. So as n goes to infinity, this is getting closer and closer to n to the 4th as n to the 4th. So it's getting closer and closer to 1. So I'm just left with 1/3, which is greater than 0. So by the ratio test, this converges. So because the absolute value converges as well as the alternating series converges, this converges absolutely. So let's look at C. Okay, at first glance, C seems a little bit difficult. So what you need to do is we need to look at what happens to cosine of n pi as n starts to 1. So this is just going to be pi cosine of 2 pi, cosine of 3 pi, 4 pi, 5 pi, and so on. In cosine, it's either going to be 1 or negative 1. So cosine of pi is negative 1. When n is 2, cosine of 2 pi is positive 1. When n is 3, cosine of 3 pi is negative 1. So it's actually an alternating series. So it's similar to, or it's actually equal to this, when n is equal to 1. So it's an alternating series. So by the alternating series test, I need to make sure that the n plus 1 term is smaller than the n term, which it is. Okay, and the limit as n goes to infinity equals to 0. So this converges. So the absolute value also converges because it's a p series with p equals to 4/3. So this also converges absolutely.